So in this training, we are going to go through the basic steps that you need to take, very simple steps that you need to take in sizing the right pump for your facility, so as not to either oversize or undersize that will, at the end of the day, affect your operations. So what are these basic steps we need to undergo while sizing the right pump for our facility? So the first step in sizing the right pump for our facility is to determine the flow rate. That is the volume per unit time that you will need in your operations. Okay, so that's the first step. Then secondly, the pressure requirement that is needed in your process, the minimum pressure that you need to overcome to deliver the liquid, okay, to your process. That is the second. And then the third, you need to calculate the pump head. Are we getting it? Okay, so the second, you need to determine the pressure requirement. That is the minimum pressure that will be needed to send the process fluid into your facility. Then the third will be to calculate the pump head, okay, which will correspond to at least that minimum pressure that will be needed to take the liquid from wherever you want to take it to your facility. Then the fourth, having known the pump head, the required head, then it is to do the pump selection itself. So we'll see all of these as we go along. So whatever you select, you want to check that the net positive suction head meets your requirement, especially what is required for that particular liquid that you are going to pump. So we'll see all of this. So let's go into the first now, which is determining the flow rate. So determining the flow rate in your process is simply determining the amount of liquid that you will need per unit time in your process. So you can see that either in your P&ID, the piping and instrumentation diagram, okay, of that particular process, you will see it, or your process data sheet. Okay, that particular process, the data sheet of the process will show you clearly the volume of liquid that will be needed per unit time in that process. So you determine the flow rate, okay? So now in determining the flow rate, you identify first the process. So once you have identified the process, that is where you need that particular liquid and from where you want to transfer that liquid from to your process. So that's the first. Then second, you define the flow requirement. Okay, like we said earlier, you need to look at the P&ID to see the flow requirement at that section of your process. If the P&ID is not there, you can look the process data, okay, data sheet. So the volume of liquid that will be needed per unit time will also be specified in the data sheet. So if you are sizing, say, for domestic use or sizing for a tank to transfer liquid to a tank, as you can see on your screen, what you need to do at this instance is to determine the volume of the tank and then also determine the amount of time that you want the tank to be filled. So as an example, assume this tank is a 1,000-liter tank and you want it to be filled in 30 minutes. Okay, so that will be 1,000 divided by 30. That will give us the flow requirement. Are we getting it? So that is it. Then from there, having known the size of the tank where you want to deliver the liquid to, then the amount of time, you calculate the flow rate. But in the case of that in your process, you will see it clearly in the P&ID. Okay, it will be clearly specified there. So volume per unit time. Are we getting it? 30 liters per minute. 30 liters per second. Are you getting it? So those ones will be specified in the P&ID or in your process data sheet. So like here now is basically the same thing, determining the volume of the tank, okay? And then this is these are the pumps, okay? Then the amount of time you want this tank to be filled, okay, will give you the flow rate. So the next step to this is to determine the pressure requirement. That particular fluid, at what pressure do you want to deliver it to your process? Okay, in this case, you need to put into consideration all the obstacles that fluid need to overcome while going into your process or while being delivered to your tank. So those obstacles, so to say, they all constitute what is called the total head, okay, that will prevent the flow of the liquid. So how do we determine the total head? So the total head, as you can see on your screen, is the sum of the suction head, the discharge head, the friction head, and also the elevation head. So we'll see how all of these are determined as we go along. So let's assume that our process or our system is just as depicted here. Okay, we are lifting from a sump to an overhead tank as an example. So the total head, which is the pressure that you need to overcome what will be exerted by this height, okay, from your suction to your discharge, okay. So from the middle of the piping, that is middle of the pump, to the maximum level that you want the liquid to be in that your tank or overhead tank, okay, becomes the static discharge head. That is the maximum head that the liquid that is going into the tank will need to overcome. That is maximum pressure. When we say head, we mean pressure. That it will need to overcome before it to be delivered to the tank. Then the suction head, which is the suction lift, okay, is the pressure with which the fluid will be taken from the sump or wherever you are taking it from. So the sum of the static and the discharge head forms the total head. But there are still other frictional forces that we need to overcome, which are that will be as a result of flowing through the pipings. So we need to determine that, okay? Then we also need to determine that will be caused as a result of the elevation, okay? So that frictional head is what is given here. So each of these pipings, they have their friction factors, okay? So the friction factor of that particular pipe that we'll be using times the length of the pipe times the flow velocity. Remember, we have determined the flow rate before, okay? Upon 2 times the gravitational force, okay, times the pump diameter will give us the frictional head. Are we getting it? So this will not add to what we have calculated earlier. Then the velocity head, okay, which is this, is gotten from the product of the flow velocity times 2 over, that is upon 2 times the gravitational acceleration. So that will give us the velocity head. But you really need not to bother yourself that much with these calculations, okay? So what you need to do is to determine that head that you need to overcome, okay, while taking the fluid to wherever you are sending it to. So the rule of thumb is that you can add 20% to that head. Okay, the sum of the suction and the discharge head. So look at this example considering the last formula. Okay, I want you to take this example, work it out, and let us have your answers. Okay, the total head that will be required in the comment section below. Okay. So once you have determined the required head, you have also determined the flow rate. Very simple steps. The next thing that you need to do is to select the pump, which is our ultimate goal, which is what we actually wanted. So once you have identified the particular product manufacturer, it's for you to request for the pump data sheet or the pump curve. Okay, so from the pump data sheet you will see the pump curve. So remember, we said you determine the flow rate, you've known the total head, that is a pressure that need to be overcome by the pump for it to deliver into your process. So once you have done that, what you need to do is to come to the pump curve. You see, this is a plot of the total head as against the flow rate. Are we getting it? So we have the efficiencies here too. Okay, we'll come to that. Here we have the net positive suction head. Okay, required. Now, what you need to do, assuming you have identified that the total head that you need to overcome in feet, okay, is let's say 60. That's the total height from our calculation earlier. Say it's 60 or 65, which is about the midpoint between 60 and 70. Then assume also that the flow rate that we have determined earlier is say 300 gallons per minute. Are we getting it? So remember, this is the speed of the particular pump that we are looking at. So now if you look at that, you will see that if you plot this up, the intersection between that 75 and this 300 is about this point. Okay, so if you look at it, you see that it is between these two particular pump, this and this, a 7.5 horsepower pump. Okay, and then here will be about 9 horsepower pump. Are we getting it? So here is 7.5. So the next higher is 10 horsepower. Okay, and since our point is here, remember we said 65. Okay, so since our point is here, it means that since our point is here, which is between, okay, this particular is between here and here. Okay, so the next higher one is the 7.5, not 10 horsepower. So it's between 5 horsepower and 7.5. So the next higher one is 7.5. Since we cannot go lower, so what we will take is the 7.5 horsepower pump. Okay, that is what will be able to give us that required flow rate. Okay, and overcome that pressure. Remember too that we have taken something higher, which means that it will work, that is, it will be able to overcome the pressure that the head that we have calculated earlier, because the 7.5 have a higher head. Are we getting it? Then if you also look at the efficiency, because that is another very important factor, if you also look at the efficiency of the 7.5 horsepower, okay, you see that the efficiency is about 74. okay, about 74, between 74 and 78. So which means that is fair enough. Are we getting it? Compared to those with a lower efficiency. So the selection for this particular requirement is 7.5 horsepower. Okay. Now remember, you know the flow rate, okay, and the total head that you need to overcome. So it's just for you to, as you look for the intersection between the total head and the flow rate. Okay. So the closest pump to that particular position, which is 7.5 horsepower, is what we are selecting for our application. So here is another example. Okay, so the operating head is the operating point is the intersection between the head and the flow rate, as we can see. So here the head is assumed to be 5.5, and then this is the flow rate extrapolated up. Okay, so this is the intersection. So you see that the closest pump is the next higher rating is this 7.5 horsepower pump. Okay, so that is what will be selected, and the efficiency too, you see that is 74%. So which is okay. So once we have determined that this is okay, then look at every other parameters, especially dimensions and what have you. Then we can choose that particular pump for our application. So the next thing that we need to do, we have selected that pump now. The next thing we need to do is to determine the net positive suction head that is required. Okay, so the liquid is what we are going to consider in determining the net positive suction head. We'll look at the liquid that we want to pump, then we'll look at the vapor pressure of the liquid. Remember that if the net positive suction head is lower than the vapor pressure, okay, bubbles will be formed, and that can lead to cavitation. So now you determine the net positive suction head by determining the vapor pressure of the liquid. So you want something that is higher than the vapor pressure of the liquid. Remember, we took 7.5 horsepower. Okay, so this 7.5 horsepower, if you look at it, you will see that at that particular point, you see that the net positive suction head, okay, is about 50, 60, 70, 80. Are we getting it? So it's about 80. So if the vapor pressure of our liquid is below that 80, then we are good. But if it is above that 80, of course, we cannot use that pump. Assuming now that since we have selected this, and the net, assuming what we selected is this 5 horsepower, okay, at this flow rate, which means that we have the intersection at around here, okay, and then the net positive suction head required is about 50. Then if the vapor pressure of our liquid is about 60 or 70, it means that we cannot use that particular pump. So the thing is that we need to select a pump with a net positive suction head pressure that is higher than the vapor pressure of the liquid that we want to pump. Okay, so by way of recap, the selection of the pump for our system, for our process, is a very simple process. Okay, so the first step is for you to determine the flow rate, the rate at which you want to deliver the liquid into your process, which is the volume per unit time. If it is a tank, you identify the volume of the tank, then divide by the time you want the tank to be filled. That will give you the flow rate. Then for your process, you look at the P&ID, you will see the flow rate there. Or you look at your process data sheet, you also see the flow rate there. Okay, so after determining the flow rate, you need to determine the total head, that is total pressure or total force that the fluid you want to pump will need to overcome before it will be delivered into your process or into the tank. So as we saw earlier, the total head is the sum of the discharge head to the suction head. Then you have to consider the frictional forces that will be exerted on the flow by the piping, and if you have valves and the rest in line, in the line of flow, of course, those will impose some restrictions to the flow. So all of those you have to determine. Okay, so like we said earlier, a rule of thumb, you can add say 20%. Are we getting it? So that what you will come up with at the end of the day will be something that will take into cognizance the frictional force, all other forces that will act against the flow. Then, having known the flow rate and the total head, okay, you take the pump curve. The intersection between that flow rate and the total head, okay, will be the operating point of the pump that you actually need. So the closest pump to that point, okay, in horsepower will be what you will select. Then finally, you look at the net positive suction head of that pump that you have selected, if it must be above the vapor pressure of the liquid that you want to pump, so that you avoid cavitation in the course of your normal operation. So here we have an example. Okay, so we want you to look at this example very well, and then we want you to solve it. Okay, find a solution to this particular example and drop your answer in the comment section.